Here we go. We are going to start graphing sinusoids, which means we are graphing sine and cosine functions. First thing we do before we graph it is first make sure it's in standard transformation form, and all of these homework problems I gave you are already in that form, so we don't have to worry about that. The next thing you need to do is set up your dinner table, or set up the alphabet here. And the alphabet we use is A, B, C, D, P, and R. And all of these letters refer to a piece of the function and kind of the characteristics of what this graph will look like. So A is the amplitude, and that's the number that's being multiplied by sine or cosine. So in this case, it's going to be 3, which means it's 3 up and 3 down from the center of our graph, or the axis points of our graph. The B is the number of cycles in 2 pi. That's the number that follows directly after the sine function. So this is 2. So this means it's going to repeat itself twice from 0 to 2 pi. We don't have a phase shift, and we don't have anything moving the graph up or down. Our period, we're going to use a formula for, and our formula is always 2 pi over the absolute value of b. And so we just figure out what our b value is. It's 2, sub it in, 2 pi over 2, divide it out, and we get pi. So this is the length from 0 to pi. We'll have one sinusoidal wave. And then the last thing we're going to do is find the range. So the range is calculated by a formula. It's d minus the absolute value of a and d plus the absolute value of a. So if everything's starting at 0, the height of our graph is going to be 3, and the minimum of our graph is going to be -3. And so we just write it in interval notation, 3 to, or -3 to +3. And then the last thing we want to do is we want to find out our critical values. So I'm just going to kind of do this off to the side down here. The critical values, and the way we do this is we take our period and we say from 0 to pi, we're going to have some important values, some of our axis points or our high points or our low points. And so the next thing I'm going to do is I'm going to take this, I'm going to cut it in half, because all of these points are evenly spaced. So now I partition the graph in half, or I cut it in half, and then I'm going to cut it in half one more time. And I get pi fourths. I want to leave these as fractions, and this pi fourths is the interval in which my graph will be spaced out. Okay, so it's really important that you figure out this piece right here. And then all that's left is just putting together the graph. So here we go. We got a maximum of 3, we've got a minimum of 3. We know we're starting at 0. We have no phase shift, so this is where we start our graph. And then we're adding our intervals each time. And so just kind of make them evenly spaced. We're going pi fourths. And you can simplify as you go, or you can just add them all up and then go back and simplify. So pi fourths, my next one is going to be 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. And we want to do 2 cycles. So that's 8 critical values. 1, 2, 3, 4, 5, 6 pi fourths, 7 pi fourths, and lastly 8 pi fourths. And then from here you're going to plot your axis points, or your critical values. And so remember our little trick to remember which method we go about graphing it. It's sine, so we're using Sahala as our acronym to remember the order in which the sinusoid kind of appears. And it starts with the S stands for sine, and then A is the axis point, so that's at 0. And then we go high, axis low, axis high, axis low, and it just keeps repeating itself forever and ever. And then we graph it. Nice, smooth, continuous curves. Just a sketch, but it should reflect the sinusoid that we are graphing. And there you go, number 1.